Okie dokie, so let's come back and let's look at some central limit theorem examples. So now I have erased the theorem, which again was ugly, but we still have its result, and its result was that we get this new big z-score that we can use as long as we have a sample size that is greater than 30. So here is our first example, and remember, actually this first one is true. Okay, most of them I make up, but this one is actually true. So this example is actually true, and it says the mean meat consumption per year per person is 250 pounds with a standard deviation of 25.3 pounds. Okay, yeah, so the meat consumption problem I found this. So the average amount of meat, the mean meat consumption per year per person is 250 pounds, which if you think about it, if you see the number, you go, oh my God, that's horrible. But then if you really think about that, if you are a meat eater, okay, that's less than a pound of meat a day, which I think a lot of us eat less than a pound of meat a day. But just think about this, if you have like bacon or sausage with breakfast, and then you have like a turkey sandwich, and then maybe you have a hamburger or a steak or something for dinner, you're definitely eating about 250 pounds a year. Okay, now obviously we know some people that just wolf them down, hamburgers and bacon and everything, but yeah, it's definitely not as bad as it seems. It's just startling when you see it. But the really big thing that always gets me is for every vegetarian, because remember this is the mean, so for every vegetarian that eats 0 pounds, it means there's a person on the opposite flip side that eats like 500 pounds per year. And that just, wow, that's a lot of meat. Yeah. Anyway, so true example here. Notice what's missing though. The word normal is nowhere to be seen, okay? Last time when we were putting problems up there, I wrote the data is normal, the data is normally distributed, but it's not there this time. Now, let me ask you the question I want to ask. So our first example here says, find the probability a sample of 44 people eat a mean more than 255 pounds. So there's the problem. Now it looks similar to what our problems looked like last time. Find the probability, eat more than 255 pounds, but there's an extra little bit in there. So, and that extra little bit is very important. So first off, we're not talking about a single person, we're talking about a sample of 44. And that sample of 44 is important because that tells us that we're looking at a sample greater than 30, which means we get to assume normal. Okay, so we get to assume normal here. Now the next thing that's important is the fact that it's talking about a mean. It's talking about these 44 people eating a mean more than 255 pounds. And that part tells us that we're going to use the big z-score. Okay, they're talking about a mean, which means we're talking about that value right there. Okay, so that's what you're looking for. A little bit different in the question, sample size and the word mean. So let's go ahead and use this to find our z-score. So we're going to go z equals, and we're going to take the mean that we are interested in. Okay, now there are two means running around. So this 255 comes from our sample. So the 255. But what was the original mean? That goes back to the original problem, and that was 250. Then we're gonna divide by the standard deviation, 25.3. But that guy is divided by the square root of our sample size, 44. Boop, boop. And like I said, parentheses there. So let me show you on the calculator what it should look like. Calculator's been sitting in the barn and it got kind of dusty. Okay, so here's your calculator. So we're gonna go 255 minus 250, and we hit enter, okay, as always. Then we're gonna divide it by parenthesis 25.3 divided by the square root of 44. Now, as I said, for a lot of you, this is good enough, but if some of you it might not be, you need to get out of the square root. Okay, so you can use your arrow to get out of the square root if you need to, and close the parenthesis. So in the end, if it looks like this, boop, then you're getting the correct answer. Okay, so take a little note of that. That's what it should look like in your calculator with parentheses and everything. So I get a z-score of 1.31. All right, so we used our new big z-score. We've got our z-score. Now from here, nothing else changes, okay? Everything is the same as it was in our original examples. So if we do draw ourselves a little graph, 1.31 is over to this side, right? And it said that we wanted more than that, so we're shading to this side. So now we're going back to our calculator. We're finding normal CDF, okay, our normal CDF, and then we are going from 1.31, to 10,000, right? Because we're going big. And when you do that, you should get an area of 0.0951. Now, just because I wrote this number on the board, don't just trust that that's what it is. Make sure that you practice it yourself so that you know. Even if you have to push pause on the video, push pause, stick it in your calculator, make sure that I'm correct, that you know how to do it, everything works. And then again, remember, we're going to answer our question. So don't leave that notation, that's ugly. So we're going to say the probability that X bar, the mean, is greater than 255 is 0.0951. Okay, so let me stick up another one here and we'll do another one. So this second one says, find the probability a sample of 50 people eat a mean between 200 and 255 pounds. All right, so again, we're looking at the setup. It looks like, finding the probability. Okay, we know how to do that. Here's our sample. Are we large enough to assume normal in this sample? Yep, we're bigger than 30. So we can definitely say normal. And this guy right here, this mean, tells us that we're using our big z-score. Okay, so those are the words that are kind of changing things here. Now, this time though, they've got two values that they want us to look up. Okay, so we've got to find two z-scores, just more practice basically. So let's go ahead and find the z-score for the 200. So remember, we're going to take 200, the value we want, then we go back to the original and subtract the original mean. then we divide by the original standard deviation divided by the square root. Now don't get caught. This isn't the last example. The square root here is going to be the square root of 50. Yes? So 200 minus 250 divided by, or enter, divided by parenthesis 25.3 divided by square root 50, close parenthesis. And again, the hope is that yours looks like this. Okay, and if we hit enter, boop, I got negative 13.97. Now at first glance, I'm like, wait a minute, that seems awful weird for a z-score, but it's actually not negative 13.97. Let me write it down first, because 200 is very far away from 250, isn't it? Okay, that's way lower. So having a weird z-score, it does happen every once in a while, okay? Now we need a z-score again for the upper end. And again, you might go, wait a minute, we just did 255 in the last example. Is it gonna be the same z-score though? Okay. It's not gonna be the same because what are we dividing by this time? The square root of 50. So we're starting off with the 255 minus 250. We're dividing by the 25.3, and then we're dividing that by the square root of 50. And that is most definitely going to change our z-score. So try plugging this into your old calculator, and you should end up with 1.40. So this sample size definitely affects the z-score. So we switched our problem, so we switched our sample size. Okay. But we got a weird one and we got a regular looking one. So let's go ahead and look at our graph. Okay, so we're going for like way out here, right? Negative 13.97. Here's the middle. Here's 1.40. So again, not to scale or anything, but the idea is that we're looking for everything between those two values. Okay, so back to normal CDF. Go to normal CDF, put in your two endpoints. This time we actually have two endpoints, no 10,000s. So put in your two endpoints and let's see what pops out of the old calculator. Hopefully you should get 0.9192. Okay, so practice that. Make sure that that's what popped out of your calculator when you use your normal CDF. And then we're gonna say the probability that X bar is between 200 and 255 is equal to 0.9192. All right, so let's move on. Let's change the example altogether just to kind of get new numbers up here and make sure that we're able to switch things out when we have new numbers. Now, this next example is made up. I don't know what the numbers are, but the cockatoo is one of the loudest birds in the world. So the cockatoo does scream very, very loud, but these numbers are not true. So this says a cockatoo's screams have a mean of 93 decibels. Again, just I picked a number. Okay. With a standard deviation of 4.2. The data is normal. So we're using the cockatoo as our example because one of our class members who has learned every lecture of statistics right along with you is Handsome. Now, Handsome is a very special bird because he does not make a lot of noise. Aren't you a good boy? See, did you ever know he was even sitting here? Yep. So Handsome knows a lot of calculus and a lot of statistics, don't you? Who's a good bird? Okay, he's gonna go back and sit and watch some more. Okie dokie. So we've got our mean, we've got our standard deviation, and this one actually went back and gave us the whole normal thing. All right, okay, well, so let's look at the first example. So the first example here says, find the probability a sample of 35 cockatoos have a mean scream less than 90 decibels. Now, I'm using this example on purpose because I want you to have to think about this a little bit more. This word right here, normal, it trumps everything. It tells us that no matter what, we can do the problem, we can start the problem, no big deal. So that allows us, no matter what I write here, to draw our graph and do our problem. But what I need you to think about is, now that I've asked you the question, how do we do this problem? And the question is this a little z problem or is this a big Z problem? And remember, little z is where we're talking about a single value, okay? Big Z is where we're talking about a mean, a group, a sample. So we are talking about a sample here and their mean, aren't we? And because of that, it means that we use big Z. So we're not using big Z here to make it normal because it was already normal. We're using big Z because we're talking about a sample. So a sample rather than a single. So for big Z on this guy, we're looking at having a mean at 90 decibels minus the original mean, which goes back all the way to the top, of 93, all over the standard deviation, which was 4.2, all over the square root of 35. Okay, again, boop. So as always, 90 minus 93, hit enter, then divided by parentheses 4.2, divided by the square root 35, close your parentheses. And again, the hope is that yours looks something like mine. Get that up there in the right area there. Okay, so looks like a z-score of negative 4.23. Okay, negative 4.23. Oops, what did I do with my purple pen? So getting that z-score is, the biggest part of this problem. So big Z because we're talking about a sample. Now we go back to our normal CDF. All of that is the same. Okay. So we're looking at a z-score that's way over here, 4.23, and then we're shading less than, aren't we? So when you do your normal CDF, you've got a boundary over there of negative 10,000, right? So boundary over there up to negative 4.23, and if you stick that in your calculator and fiddle it all out, we're gonna get a bunch of zeros here. 0, 0, 0, 0, 1. And here's the dealio. I know we normally go to 4 decimals, but if you go to 4 decimals, that puts this area at 0, which means that puts this probability at 0. Can we have a probability? I mean, we can have a probability of 0, but should we? No. So we have to go out at least until we hit some digit other than 0 to show that there actually is a probability this could happen. It's very, very, very slight, but that doesn't mean it can't happen. Okay, so we would say the probability that X bar is less than 90, so the mean is less than 90, is 0.00001. Okay, let's see what I have next. Okay, so the next one, put it down here. So this one says, second, find the probability handsomes scream is less than 90 decibels. So I wanted both of these problems on the board at the same time so that you really can see the difference between them. So it looks like we're asking for the same thing, less than 90 decibels. Why aren't they the same thing? In this example, how many birds were we looking at? We needed 35 cockatoos to do this. In this example, how many cockatoos are we looking at? 1 cockatoo. 1 cockatoo, just handsome. So that means that we are not using big Z. We're going to go back to using just our little basic Z that we've been using for the past couple weeks. Okay, so this is a little z problem. And remember, the whole set thing was normal, so we don't have to worry about sample size or anything like that because this problem was normal to start with. So little z, so we're going to say z equals, and we're going to start with our 90. We're going to subtract the original 93, and we're going to divide by 4.2. But this is little z, so there is no dividing by the square root of n on this one. I'm being given a snack of goldfish crackers. Thank you. All right, so I got negative 0.71 for my z-score. Did you get the same thing, hopefully? All right, so if we set up our graph, negative 0.71 is about here, we'll say. We're still shading less than. So it's still the same idea, but when we're talking about 1 cockatoo versus 35, things change. The z-scores definitely are affected by that. Okay, so remember your normal CDF, go from negative 10,000 up to the negative 0.71, and you should get 0.2389. So we can say the probability that handsome is less than 90 decibels is equal to 0.2389. Okay, one more problem. Again, so we see these two problems, we see how they're the same, or sorry, I erased it, but we see how they were the same and how they were different. Now I'm going to give you one more problem with this information, and we'll talk about how that is different as well. So this last one says, so third, find the probability a sample of 14 cockatoos have a mean scream louder than 92 decibels. Now, the question is, when you read this problem, what z-score do you use, or can you do the problem at all? right? So is it normal? Do we have big Z? Do we have little z? What are we looking at here? So hopefully you're noticing this and you go, wait a minute, didn't we say that n needed to be greater than 30? How come in this case 14 is going to work okay? 14 is only going to work for us because what did it say way back from the original? It said that the data was normal. So it doesn't matter what size our sample is, it's going to be normal no matter what. It started normal, it's going to stay normal. Okay. So even though it's 14, we're good to go. Now, if it didn't say this, if this line hadn't been here, would we be able to do this problem? No. Okay, but we are okay. So the sample size is okay for us. Then we need to decide what z-score are we using. Are we talking about a group of cockatoos or one cockatoo? So we're talking about a group, which means we use big Z, right? So we got big Z going on here. All right, so let's work through this one more time. So we'll go for our z-score. This time we're interested in 92 decibels. Subtract our original, which was 93. Divide by our standard deviation, 4.2. But then remember, we still have this value here, so we're going to divide by the square root of 14. All right, give that a try in your calculator. 92 minus 93 divided by, oops, what did I do? 4.2 divided by the square root of 14. So I got a negative 0.89. If you put that on your graph, negative 0.89 is definitely over here. But just because it's over here, which way are we shading? We want louder. So we'll be shading this way. So for your normal CDF, you're going negative 0.89 all the way to 10,000, and that should give you 8133. So we can say that the probability that X bar is greater than 92 is equal to 0.8133. Okay. Okay, so you've seen just about every example that I can give you with the central limit theorem. Big sample size, small sample size, says normal, doesn't say normal, using big Z, using little z, sorry. So there's all sorts of just different arrangements there that you have to kind of go through. Read the problem carefully before you jump in. Decide which z-score it is before you just start. Take a minute on each one, all right? That will see you through. So now we can do the problem when the data is normal, and now we can do the problem when the data isn't normal. Yay! Okay. All right, so I will see you next time.